DJI Avata 2. If you have ever flown the first DJI Avata, you'll understand the ease of taking control and quickly going from beginner to full speed flying. When flying with DJI's motion controller, the movements to fly Avata is natural, meaning anyone can do it. Let's use myself for instance. I am not an avid FPV flyer. I don't build any of them, and I'm for sure not out there doing flips and flying in and out of buildings with them. My experience with FPV was a 1-minute flight demo at a public safety drone demo by UVT last summer. Yes, Avata is being pushed to law enforcement for house clearing usage. While crashes with a Mavic, Air, or mini drones are usually not good, FPV drones are expected to have some crash resilience to them. Clipping branches, walls, and the occasional metal pole is not unheard of, so the Avata 2 has to be built to take it. Overall, the quality is great. The rotor guards protect the rotors from getting any damage if you graze a wall, clip some leaves, or even fly a bit too low into the tall grass. Avata 2's turtle mode also allows you to flip the drone over and continue flying after a tumble. And yes, I've had to use it a few times. I wish there was a shortcut. AMBIDEX robot. In this section, we describe the main features of the tendon-driven mechanisms underlying the AMBIDEX. More general information and detailed design specifications of the AMBIDEX are available in A5. The kinematic structure of the AMBIDEX manipulator, shown in Figure 1, consists of a 3 DOF shoulder, 1 DOF elbow, and 3 DOF wrist. Each joint is actuated by cables driven by electric motors. The shoulder employs a capstan mechanism for low backlash and high backdrivability, while the elbow, wrist. Engineers from Naver Labs have developed the AMBIDEX cable-driven robot capable of precise movements and taught it to learn humans' physical intelligence. The robot can memorize actions and perform them autonomously. For example, peel a vegetable and catch a flying ball. The authors declare that they have no known competing financial interests or personal relationships that could have appeared to influence the work reported in this paper. 6G Vision for 2030. In November 2023, the International Telecommunication Union's radio communications sector, ITUR, reached a consensus on the global vision for IMT 2030 6G, which is expected to be a fundamental milestone in developing 6G. Notably, the ITU's consultation process included countries all around the world. While there has been some concern that geopolitical pressures would create a de facto split in standards, work is ongoing to avoid this. It is extremely rare to find anyone within the telecoms community advocating for anything other than globally unified technical standards. The published framework, approved by the ITU Radio Communication Assembly, RA 23, in November 2023, outlines some key vision areas, such as capabilities and use cases, which we will explain in this article. Usage scenarios of IMT 2030 will expand on those of IMT 2020. In addition, it will also enable new use cases arising from 6G capabilities, such as AI and sensing, which previous generations of IMT were not designed to support. AKKA's flying train. The idea is that you head to your local train station to board the train like 2, which takes you straight to the airport. The pod then moves onto the runway where a cockpit and wings are attached to the passenger train before taking off. Upon landing, the train/fuselage detaches from the wings and rolls out of the airport to local train stations to drop you at a convenient location. The Link and Fly aircraft comprises a 162-seat plane with an option for cargo delivery that can hold a maximum payload of 21,000 kilograms. Engines are mounted on a large, delta-shaped wing with a span of about 49 meters. The craft is envisioned with a range of 2,200 kilometers, a cruise speed of Mach 0.78, and a maximum cruise altitude of 39,800 feet. AKKA's aircraft concept is an ambitious project as it would require the entire industry of air travel to change in order to accommodate the transportation of an aircraft from a local train station. However, according to an interview with Bloomberg, CEO of AKKA Technologies, Maurice Ricci, has had a chance to pitch the flying train concept to Boeing. CyberDog 2. Xiaomi CyberDog 2 is a bio-inspired quadruped robot that is powered by NVIDIA's Jetson Xavier NX AI supercomputer for embedded and edge systems, which includes 384 CUDA cores, 48 Tensor cores, a 6-core NVIDIA Caramel ARM version 8.264-bit CPU, and 2 deep learning acceleration engines. Xiaomi CyberDog 2 is paired with 8GB 128-bit LPDDR4X RAM, 16GB eMMC 5.1 storage, and 32GB of near-industrial-grade SSD. Xiaomi has improved the mobility of its CyberDog robot with self-developed CyberGear micro-actuators. These actuators make the robot more agile and capable of performing more complicated maneuvers, such as continuous backflips and fall recovery. With its in-house developed high-performance servo motor, Xiaomi CyberDog 2 has a wide range of movements including running, jumping, turning. Satellite 5G. Since its inception, mobile networking has existed independently of satellite technology. But the development of 5G architecture holds promise for a new generation of satellite operators to help provide unprecedented connectivity and futuristic applications with a tech focus. Though satellite internet faces significant challenges in bringing broadband to users on a wide scale, many companies have already begun to deploy it. The development of the 5G satellite spectrum offers a great complement to burgeoning 5G terrestrial connectivity. Traditional communication satellites orbit the Earth from about 22,000 miles up. Their geosynchronous orbit means that geostationary satellites move in synchronicity with the Earth, so that the satellite remains directly over one point as the Earth rotates. Ground-based antennas point directly at the satellite to receive a signal. Unlike a geostationary satellite, a 5G satellite circles in a low Earth orbit, LEO, generally between 300 and 1,200 miles above the Earth. These LEO satellites must move almost 2.5 times as fast as geostationary satellites do to remain in orbit. As a result, Microsoft HoloLens 2. I'm in a tiny room in a basement somewhere in Microsoft's Redmond, Washington headquarters, wearing an early version of the HoloLens 2 headset. In front of me is a very real ATV, which is missing a bolt. Not quite at the corner of my vision, but certainly off to the side. I see a glowing indicator pointing to a bucket of the right bolts. I walk over, bend down to look more closely at the shelf, and grab one. Back at the ATV, a holographic set of instructions hovers above it, telling me what to do and pointing to the exact spot where the bolt needs to go. After a couple of minutes, I've successfully fixed the thing, guided by holograms. I tap a holographic button on the guide to close out the instructions. This sort of demo is quickly becoming commonplace for tech journalists like myself. But if you read the previous description closely, you'll find that there are 3 key pieces of technical innovation hidden in plain sight. Here they are. I saw a hologram off to the side because the field of view in which they can appear is much larger than before. I bent down and didn't worry about an awkward headset shifting around because it was better balanced on my head. I pushed a button just by pushing a button. Nanoscribe. The Nanoscribe Photonic Professional 3D printer is an important tool for the fabrication of 2D and 3D structures on millimeter, micron, and submicron scales. Unlike conventional 3D printing, the Nanoscribe 3D printer fabricates structures via direct laser writing, which utilizes the concept of two-photon polymerization for printing of high-resolution 3D objects with high-quality surface finish. The Nanoscribe 3D printer, located in UCL Chemical Engineering, offers a flexible approach towards fabrication of high-resolution structures. Specialized objective lenses, photopolymerizable resins, and sample holders allow for printing of structures from micron and submicron scale to as large as multiple centimeters in size. Structures may be printed on silicon or glass and can be removed from the underlying substrate if required. Nanoscribe's bespoke software enables user-friendly processing of CAD-based designs for generation of high-quality structures to the desired specification. Structures generated from the Nanoscribe 3D printer have been employed for fabrication of micro-optics, quantum dots, photonic integrated circuits, biological. Electric Atlas Robot. This week we announced the retirement of our hydraulic Atlas and unveiled what comes next. a fully electric Atlas robot designed for real-world applications. The next generation of the Atlas program builds on decades of research and furthers our commitment to delivering the most capable, useful mobile robots solving the toughest challenges in industry today. With Spot, with Stretch, and now with Atlas. A decade ago, we were one of the only companies putting real R&D effort into humanoid robots. Now the landscape in the robotics industry is very different. Our customers have seen success with Spot and Stretch, and they are eager to tackle the next challenge with Atlas. Given our track record of successful commercialization, we are confident in our plan to not just create an impressive R&D project, but to deliver a valuable solution. Having a meaningful impact outside of the lab requires collaboration beyond our walls. Following the commercial deployment of both Spot and Stretch, we know how to deliver real value for customers. Similar to our Stretch rollout, we will be partnering with a small group of innovative customers, beginning with Hyundai, to test and iterate Atlas applications over the next few years. Nanotechnology. Nanotechnology was defined by the National Nanotechnology Initiative as the manipulation of matter with at least one dimension sized from 1 to 100 nanometers, nm. At this scale, commonly known as the nanoscale, surface area and quantum mechanical effects become important in describing properties of matter. The definition of nanotechnology is inclusive of all types of research and technologies that deal with these special properties. It is therefore common to see the plural form nanotechnologies, as well as nanoscale technologies, to refer to the broad range of research and applications whose common trait is size. 1. An earlier description of nanotechnology referred to the particular technological goal of precisely manipulating atoms and molecules for fabrication of macroscale products, also now referred to as molecular nanotechnology. 2. The concepts that seeded nanotechnology were first discussed in 1959 by physicist Richard Feynman in his talk, There's Plenty of Room at the Bottom, in which he described the possibility of synthesis via direct manipulation of atoms. Nanotechnology is the science and engineering of functional systems at the molecular scale. This covers